Hi everyone, it's Sorkin. Today we have a problem when we are given the head of a singly linked list and we need to return true if it's a palindrome or false otherwise. So what's a palindrome? Palindrome is a sequence when forward and backward it reads the same. So for example, in this case, 1, 2, 2, 1, and the backwards it reads the same, 1, 2, 2, 1. It's a palindrome. So we are returning true. In this case, we are returning false because forward it reads as 1 and 2, and backward it reads and the 2 and the 1. So how we are going to solve this problem? Let's take one more example. Let's say that we have here 1 linked list, we have here 2, we have here again 2, 2, 2, 2, and 1. So is it a palindrome or not? Yes, it's a palindrome because in this case, forward and the backward, it reads the same. So 1, 2, 2, 2, 2, 2, 1, and the backwards, it reads the same. So how are we going to solve this problem? In our case, we are going to use two pointers, fast pointer and the slow pointer. So slow pointer and the fast pointer. So when we are starting from the beginning of our single linked list, we are moving slow pointer 1 at a time, and the fast pointer we are moving two steps at a time. So for example, in the first step we are moving our slow pointer here and we are moving our fast pointer here. So then we are moving again our slow pointer here in the next iteration, and our fast pointer we are moving two steps. So we are moving our fast pointer here. In the next step, we are moving our slow pointer here, and we are moving our fast pointer. We are moving our fast pointer until the end of our single linked list. So at this point, so what we have a slow pointer. Slow pointer points to exactly to the middle of our linked list. So what we can do in this case? So in this case, we need to compare this element, right? Element from the end, first element from the beginning, and the first element from the end. And then we need to compare second element from the beginning and the second element from the end, and so on. So how we are going to do that? We are going to take the starting from the next element, right? So we are going to take this part of our linked list and we are going to reverse it. So we are going to reverse it, and after we reverse it, so we have 1, 2, and 2, right? So because we have reversed that, and now and as a next step, so we are moving our fast pointer. We are moving to the beginning of our linked list, and now we are moving our slow pointer and fast pointer one step at a time. So we are comparing first. We are comparing 1 with 1. Are they equal? Yes, they are equal. So we are moving to the next element. 2. Is 2 equals to 2? Yes, it's equals. How about the next element? Next element also, 2 is equals to 2. So we are returning true in this case, because this element, it doesn't matter what is in the middle, right? In the middle it might be 5. It still would read backward, and forward it would read the same. So, and in this case, so we are moving, and if at any point, let's say that we have not 2, here we have 7, right? So here we have 7, so then this element would be 7. So we are comparing again, we are going step by step and comparing. We are comparing first element with the first element, second with the second, and third with the third. If at any point they are not equal, the values of our node are not equal, then in that case we are returning false, otherwise we are returning true. Okay, first thing that we do here is we are checking that if the head is null, or if there is only one element, then in that case we are returning true, because in that case our linked list would be a palindrome. If not, then we are creating two pointers, slow pointer and the fast pointer, which are pointing to the head of our linked list. And the next step is we are moving our slow pointer, and we are moving our fast pointer. With slow pointer we are moving one step at a time, and the fast pointer we are moving two steps at a time. After exiting this while loop, so what we do is we are from the middle of our linked list, we are reversing our linked list. So we are assigning a variable previous to none, and also our current is pointing to the middle of our linked list. So in the next step, we are taking the next node, which is pointing to our current, whatever the current is. So whatever our slow pointer node is next, and then we are to our current next, we are assigning our previous, and to our previous we are assigning our current, and our current is pointing to the next node, which is our current next. So after exiting this loop, so we have our linked list reversed starting from the middle. So what we do is our linked list, our slow pointer points to the previous, which is the reversed head of the reversed linked list, and the fast pointer points to the head of our linked list. So what we do is, in the next step, we are going step by step, and at each step we are comparing the value of the fast pointer, and we are comparing the value of the slow pointer node. And if at any step they are not equal, then in that case we are returning false. If they are equal, so we are, after exiting this loop, if we haven't found any values that are not equal, it means that they are all of the values are equal, so then we are returning true. What's the time and space complexity of this solution? The time complexity is of n, because we are going over our linked list only once, so it's of n, and the space complexity is constant. Java solution is identical. So what we do first, we are checking the head. If head is equals to null, or if there is only one element, so head next equals to null, then in that case we are returning true, because our linked list, in that case palindrome, because forward and backward it reads the same. So in the next step, what we do, we are creating two pointers: slow pointer, which is pointing to the head of our linked list, and the same for the fast pointer, which is also pointing to the head of our linked list, and we are moving them simultaneously. Slow pointer we are moving one step at a time, and the fast pointer we are moving two steps at a time. So we are going until we reach the end of our linked list. Once we exit, so our slow pointer is pointing now to the middle of our linked list. So what we do, we are reversing our linked list starting from the middle. So what we do is we are creating two variables, previous and current. So then we are taking the next node, which is the pointing to our current next. So for our current next now will point to our previous points to our current, and the current we are pointing to the next node, which we have set earlier. So after exiting this while loop, our linked list starting from the middle is reversed. Now what we need to do is we need to, starting from the beginning and starting from the middle, compare each element. For that, we are, for our fast pointer, we are setting that to the pointing to the head of our linked list, and the slow pointer points to the middle of our linked list. So what we do is we are starting to, at each point, until we reach the end of our linked list, when our S points to the null. So what we do is, at each step we are comparing the values of the fast pointer and the slow pointer. They should be equal. If they are not equal, it means that it's not a palindrome, so we are returning false. If they are equal, so we are exiting this loop, and if they are equal, then in that case we are returning true. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.